Hey yo, it's Miss Power. Let's do this Module 6 review together, right? Test tomorrow. Sorry this is up so late. Again, I had a hectic weekend. That's my fault. But, here it is now. Okay, the very first question on the test, no tricks, is going to say write the following ratio definitions. It's going to give you sine, cosine, and tangent in this order. And what you should write is opposite over hypotenuse for sine, except you should spell hypotenuse, right? Adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. Whenever people say SOHCAHTOA, what they're saying is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this is kind of like the mnemonic that a lot of people use for memorizing sine, cosine, and tangent. Cool. That'll be useful later on in the review and later on in the test, but I want you to have it written somewhere on your test so you can refer to it if you don't get your notes on your test. Okay, number one is a skill that we'll use over and over again. It's solving for x when we have proportions or ratios or fractions set up. The way most people like to do it, and the way I'll go over it, is called cross multiplication. Cross multiplication. Nice. It means you take the top of the left one and multiply it by the right of the bottom one. So 6 times 27. And that equals the bottom of the left one times the top of the right one. And this will be 18x squared. We're not going to add them. We're going to multiply them. Cool. 6 times 27 is 162. Now, to solve for x, we want to get rid of the 18 and we want to get rid of the squared. I'm going to get rid of the 18 first. I'm going to do PEMDAS backwards and get rid of multiplication first. This side then becomes 9. This side becomes x squared. Now, to get rid of the squared, I'm going to take the square root. The square root of 9 is 3, of course. But because we're the ones taking the square root, we should also have -3, plus or minus 3. The way to remember that we're going to have two answers here is anytime we have x squared in our answer or in our problem, we're going to have two answers, or we should expect two answers. Okay. Oh no, I think this said 7. Nice. Cool. For the next one, we're still going to cross multiply. So numerator times denominator. 7 times 30 is 210. Denominator times numerator. 6 times x is 6x. And then again, we're going to divide by 6. That cancels. And we're going to get 35 equals x. We can stop there because x is totally by itself. Nice. Number 2, the following figures or shapes are similar. Find x and y. Note the figures are not drawn to scale. Yeah, I can't draw. That's not going to change between now and tomorrow. Similar means two different things, right? Similar means, first off, all of our angles are equal. So every angle I have over here, I can just write in over here. And same over here, I can write in the ones on the right onto the left figure. And the other thing that similar means is that the scale factor between sides is going to be the exact same thing, right? So anything we multiplied 5 by to get 12, we would also multiply x by to get 9. Let's do the angles first. Let's find y first. Because we have all the angles on each shape now, we can add them up. 70, 14, nope. 55 plus y. And we can set those equal to 360. When your shape has 4 sides, when it's a quadrilateral, all the angles add up to 360. The way to remember this is if you've got a triangle, it adds up to 180. And each additional side, you add on 180 more degrees. Pretty cool. Now we're going to add up these ones. So 115 plus 55 plus 70 equals 240. And then we're going to subtract 240 from both sides and get that y is 120. Nice. For the side lengths, we can find the scale factor. So what did we multiply 5 by to get 12? To do that, we would do 12 divided by 5. So I'm doing it on my phone. And get 2.4. So 5 times 2.4 was 12. So x times 2.4 is 9, which means we should do 9 divided by 2.4. 9 divided by 2.4 to get that x is 370 or 3.75. So instead of going this way, we'll go that way, and we'll divide by 2.4. If you like ratios better than scale factors, we also could have, down here, said that 5 divided by 12 equals x divided by 9. Then we could have cross multiplied and divided. Either way works to find the sides. All right, number 3. Given that these two parallel lines are actually parallel, find the values of a and b. These are slightly different, so see if you can catch the nuance. If I'm looking at A kind of has two partners in this figure. A matches with 4, and A matches with 6, right? Because we've got these two kind of correspond to these two, as well as these two corresponding to these two. Pretty good. I'll do A matching with 4 and 6 matching with 5. Again, we could have done A over 6 equals 4 over 5 as well to set up a proportion for this A. Then I cross multiply. I get 5A equals 24. And over here, you might notice that we would have also gotten 5A equals 24, which is why it ends up being the same thing and ends up being fine. And now to solve for A, I divide both sides by 5 and get 4.8. Nice. So we got this part over this part and this part over this part. You might notice that neither 6 nor 5 is the entire side length. 6 is not the entire right-hand side, and 5 is not the entire left-hand side. However, when we're solving for B, its partners are, again, 4 and 22.5, right? I'm going to do 22.5. I'm going to say B divided by 22.5. So these two are going to be 4 over 9. The reason I'm going to do 9, the reason I'm going to add these two together is because 22.5 was its entire side length. Unlike 6 and 5, which were both the little parts, and why we were able to put them together in the purple equation, in the red equation, both B and 22.5 are the entire side lengths for their triangles. So that way, when we do this right-hand side, we want 4, which is the entire left-hand or the entire right-hand side for the little triangle, and 9, which is the entire right-hand side for the big triangle. Now we cross multiply, and we divide by 9, and get that B equals 10. Number 4. This is the wacky one. This is the one a lot of people don't like. But we can do it. The first thing we're going to do, the first thing I like to do is draw 3 different triangles, right? I'm going to draw, let's see if it'll let me do this. No. Copy, paste. Probably should have made these ones a little smaller. Nice. Wow, computers. Sometimes they're good. Who knew? Okay. I like to break this big diagram up into 3 separate diagrams. That way we can see all the similar triangles. A lot of people like to do the quadratic formula first, or sorry, the Pythagorean theorem first. This is the right triangle, so we can do 100 squared plus 20 squared, and then do the square root. and then, round to a couple decimals. Totally fine. That actually might be nice here. That doesn't look like a 2 at all. Looks better. Yeah, doing the Pythagorean theorem to solve that triangle is nice. If you don't notice that has that you can use the Pythagorean theorem there, you can notice once we get to our separated triangles. All right, let's separate these triangles. If we're looking at just first, I almost just started going. First, what I want to do is I want to pick one of these to be angle 1, and then draw an angle 1 on all of these. And I want to pick the next one to be angle 2, and draw an angle 2 on all of these. Draw on the right angle. The reason I do this is these kind of guideline angles are going to be really useful in figuring out where our given sides are actually put on these put apart angles. For instance, when I look at this small triangle, I notice that y is the hypotenuse and 10 is across from this double angle. So on the small one, I'll put y on the hypotenuse and 10 across from the angle 2, the double angle. If we're looking at this middle triangle, I notice that 22.36 is the hypotenuse and that 10 is across from angle 1. So I'll put 10 across from angle 1, just like I did over here. I'll make 22.36 my hypotenuse, and then 20 is my other side, so I'll put it where it is. And then on the giant triangle, I notice that W is my hypotenuse, Y is across from the 1 angle, and then 22.36 is my other side. Nice. Now I'm going to stop looking at this altogether and just look at these ones. Again, if you hadn't noticed that these ones could be found with the Pythagorean theorem, now that we've got 20 and 10, when you have two sides that are numbers, we can find the other one using Pythagorean theorem. Cool. Should we solve for W or Y first? It obviously doesn't matter. I'm going to solve for Y first just because it looks nicest. From here to here, the scale factor seems to be divide by 2. So from 22.36 to Y, I will also divide by 2. You get that Y is 11.18. Nice. Once I get Y, I can plug that in everywhere Y shows up in my diagram. Sorry. And then once I plug in Y for this biggest triangle, I can either do the scale factor from 20 to 22.36 and then multiply the same thing here, or I can do the Pythagorean theorem on this triangle. I'll do the Pythagorean theorem. So W equals the square root of 22.36 squared plus 11.18 squared, all square rooted. And now 22.36. That's 49996 plus oh goodness, 124.99 plus 49996 square root of 624.95, which is, who knows, because my phone is locked. Great. Square rooted. We get 24.99899, so pretty close to 25. And again, I know that we're going to round slightly differently, so if you do the process correctly, I'll be able to tell on the test. Number 5, find the measures of the missing sides and angles for the triangle. This is where the trig starts coming in. All of this was kind of last unit, or the first half of this unit, which was like similar triangles. And now we're going to start doing SOHCAHTOA stuff. So, move this over. The first one I'm going to do is angle S. This is just 90 minus 78. So this should be 12. Bada bing. Now I'm going to label this one as X and Y because I don't really like dealing with CA and CS's in my equations. So I'll label this as X and Y. And now I'm just going to write a trig equation that uses X, 56, and one of these angles. So I could write that the sine of 78 is Y divided by 56. I could write that the cosine of 78 is X divided by 56. I could write that the sine of 12 is X over 56. I could write that the cosine of 12 is Y over 56. I'm writing these equations. They're all true, right? And they're all useful. I don't need all of them, but I do need at least one of them. What I'm thinking is, when I'm looking at A, 56 is my hypotenuse. Y is my, nope, wrong. Y is my opposite, and X is my adjacent. Because adjacent means next to, and this is right next to 78. And opposite means across from, and this side doesn't touch this angle at all. So when I was doing the sine and cosine, sine is opposite over hypotenuse, so Y over 56, and cosine is adjacent over hypotenuse, so X over 56. Whereas if I was looking at S, now this is my opposite that doesn't touch my angle at all. This is my adjacent that's right next to my angle. And this is still the hypotenuse, because the hypotenuse is always, always the longest one and the one across from the 90-degree angle. So again, these ones are how I got these two. Great. I'm going to pick any one of these. It does not matter. I prefer, Laura Power, personal preference, to use the ones that use 78 because that's the one I know is right. So once I have an equation, like the sine of 78 equals Y over 56, I'm going to go on my calculator and press sine of 78. So sine of 78 is 0.978. This side is still Y over 56. And now the game is I want to solve for Y, right? If I want to solve for Y, the only thing in my way is this divided by 56. So I'm going to times by 56 on both sides. And that's going to give me 54.776 for Y, which is CS. Let's call it 78. Awesome. And now I'm going to make this a transparent selection. Dope. To solve for X, nope, brushes. Dope. To solve for X, because I already know Y, I can do another trig function. Like I can do the cosine here or the sine here, or I can use the Pythagorean theorem, right? I can say 56 squared minus 54.78 squared, all square rooted. And I will get 11.64. Again, you can use trig. Honestly, a lot of people find the trig faster. I find the trig faster, for instance. But you can, once you have two sides of a right triangle, you can always do the Pythagorean theorem. Cool. Number 6. If sine of b equals 8 over 17, label the triangle and find all values for the missing sides. Okay, so if we're looking at sine of b, we're looking at b. Let's make that brighter. Looking at b, sine is opposite over hypotenuse, which means 8 should be labeled as the opposite and 17 as the hypotenuse. So already BA or AB is 17, AC is 8. Now, to find BC, I'm going to do the Pythagorean theorem. I'm going to take the hypotenuse squared and subtract the leg squared. We'll get 225, the square root of which is 15. I already know that the measure of angle C is 90 because they told me. I'll put that one in. Now, to find these angles, I am going to take the equation they gave me, or to be honest, any true trig equation, for A or B, tangent, cosine, or cosine. But I'm gonna use the one they gave me just because I like being correct. To solve for B, we're going to plug in the sine inverse of 8 over 17 into your calculator, right? So you do 8 divided by 17, and then you do the sine inverse of that number. Which is 28.07. And then A is just 90 minus that other angle. So 90 minus 28.07, aka 61.93. Cool. Let's keep going. Find the missing angle measures. Nice. I love these. This and this are parallel lines. No other line is parallel. So what that means is that 82 and B are the same because they're corresponding. And you don't have to write this, but I'm going to say it. I'm going to write it. Corresponding. F and C are equal. So I'm just going to write that down for whenever we find one of those. 30 also goes here by vertical angles. And then angles that are next to each other add up to 180, right? So like A plus B is 180. So this one is 180 minus 82 because they're linear pairs. 58 plus E plus 90 is 180. So E is 180 minus 90 minus 58, which is 32. And that's a linear triplet. F is 100, oh my gosh, is 180 minus 30 minus 82. That's also a linear triplet. So 180 minus 30 minus 82 is 68. Then C was the same as F, so we can put in 68 there. And then D and C make a linear pair. So D is 180 minus 68, which is 112. Main thing is, if you've got a straight line and there's like two angles here, they add up to 180. We use that one a lot. And they're called linear pairs. Not that you need to know that for this test. All right, last two. Sarah is 5 feet tall. I'm assuming this one's Sarah. And at 4 p.m., she casts a 6-foot shadow. So she's 5 feet tall when she's standing straight up. Because she's standing straight up, it's a 90-degree angle. Shadows are on the ground, so we'll label this one on the ground as 6. At the same time of day, she measures the length of a shadow of a tree next to her house and finds that it casts a 26-foot shadow. So its shadow, which is on the ground, is 26 feet, and we want to know how tall is this tree. We're going to solve for x. Once we draw this picture, we're going to completely ignore that this is a word problem and just solve these similar triangles, right? The 4 p.m. and same time of day tell me that these angles are equal, so then they must be similar triangles. I'm going to set up x divided by 5 equals 26 divided by 6. I'm going to cross multiply. I'm going to do 26 times 5 is 130. Then that divided by 6 is 21.6 repeating, which is how tall this tree must be. We also could have done scale factor. We could have said 6 times something equals 26, done 26 divided by 6, and got 4.333. And then 5 times 4.333 equals 21.66666. The ratio A, this proportions, or scale factor, either way. Next, you're flying a kite. Wow, I'm so artistic. Okay. Your friend is standing directly under the kite and she's 90 feet from you. So this is 90 feet. The angle of elevation of the kite is 54. How high is the kite above the ground? So find this x, right? Let's set up a trig function. If we're looking at this angle, we have the opposite, the one that does not touch the angle at all. And we've got the adjacent. It's the one that's right next to it that is not the hypotenuse. If we've got opposite and adjacent, I want the tangent to be this. I'm going to type in tangent of 54 to my calculator. I'm going to get 1.376. And then to solve for x on this side, I'm going to multiply by 90 because it cancels. I get x equals 123.87, which is how far this kite must have been in the air. Well, I hope that's helpful. If you've got any questions, I will be here before school at 7:30 tomorrow morning. Other than that, I will see you during your test. Good luck.